My name is Nikita Shetty and my roll number is 3035, and I am going to explain some topics in the subject space dynamics from unit first. So in this slide we can come to know that what are the celestial sphere, what is celestial zenith, equator, what is equinox and what is ecliptic. So from the starting, we can know that what is celestial sphere. The celestial sphere is an imaginary sphere with the observer at its center. It is used as as a way of describing the position of objects in the sky. The stars, planets, and other celestial objects appears to be located at the surface of the celestial sphere. One of the fundamental concepts of the celestial sphere is the celestial equator. The celestial equator is a projection of Earth's equator onto the celestial sphere. It divides the sky into the two hemispheres. The the two hemispheres are northern hemisphere and southern hemisphere. So in this slide, the we can come to know the another important concept of the celestial sphere is the celestial pole. The celestial poles are the points where the Earth axis of rotation intersects the celestial sphere. The north celestial pole is located in the constellation Ursa Minor, while the south celestial pole is located at the constellation Octane. The position of an object in the sky can be described using coordinates that are similar to latitude and longitude on Earth. The altitude of an object is measured in degrees above the horizon, while its azimuth is measured in degrees eastward from due north. So we can explain the next term. So I will explain the next term called as equinox. So what is equinox? An equinox is an astronomical event that occurs twice a year when the Earth's equator passes through the center of the sun. Here you can see in this diagram. Uh, in this diagram, so causing the length of the day and night can be approximately equal in all the parts of the world. Specifically, during all equinox, the tilt of the earth axis is neither inclined nor away from the sun. There are two equinoxes in year. Those are vernal equinox and autumnal equinox. So, the vernal equinox is the spring equinox, which occurs around March 20 to 21st, and the autumnal equinox, which occurs at the September 22nd or 23rd. The vernal equinox marks the beginning of the spring in the northern hemisphere and fall in the southern hemisphere, while the autumnal equinox marks the beginning of fall in the northern hemisphere and spring in the southern hemisphere. Now, what is ecliptics? Ecliptics is an imaginary line on the celestial sphere that represents the path that the sun appears to take across the sky over the course of an year. As viewed from the Earth, the ecliptic is also used as a reference point from defining the celestial coordinate system, where the ecliptic is one of the two great circles used to define the celestial equator. In this diagram, you can see the north celestial pole, ecliptic, and the celestial equator, which is inclined at degree of 23.5. During the equinoxes, when the ecliptic intersect with the celestial equator, day and night are of equal length all over the world. So, in this diagram, we can see the anatomy of the earth, whereas the cores of the earth are described. The inner part of the earth is called as inner core. After that, mantle is core is there. After that, mantle is there, and the last section of the earth is the crust. So now, what are the layers of the earth? The uppermost layer of the earth is crust. After that mantle comes, after that outer core and the inner core. Inner core is having very high temperature, and now let's see the layers of Earth's atmosphere. There are mainly five atmosphere of the Earth. Earth's atmosphere. The Earth's atmosphere is divided into the five layers based on the temperature and their heights above the surface of the Earth. Starting from the surface of the Earth and moving upwards, these layers are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So, what is troposphere? The troposphere is the lowest layer of the Earth's atmosphere, extending from the surface up to 7 to 20 km, that is 4 to 12 miles in height. Depending on the location and season, this is where weather occurs. It contains most of the air we breathe. The temperature in the troposphere decreases, the altitude increases. Now we can see when the temperature of the troposphere decreases, the altitude increases. The temperature of the troposphere decreases as altitude increases. So, in troposphere, passenger planes can fly, hot air balloon also may fly, and after that, stratosphere. The stratosphere is the layer above the troposphere, extending from about the 20 to 50 kilometers, that is 12 to 31 miles in height. It contains the ozone layer which absorbs the ultraviolet radiation from the sun. The temperature in the stratosphere will increase with the altitude. So here we can see that in stratosphere region, radio radio the temperature is minus 56.5 5 degree Celsius to minus 2.5 degree Celsius. So in next slide we come to know that what is the uh, third layer of the earth, mesosphere. Mesosphere is the layer above the stratosphere, extending from above the 50 kilometers to 85 kilometers, that is 31 to 53 miles in height. Meteors burns burn up in this layer, creating shooting stars. The temperature in the mesosphere decreases with altitude. Here you can see that the range of the mesosphere is 85, from 50 kilometer to 85. So in thermosphere, the thermosphere is the layer above the mesosphere, extending from about 85 to 600 kilometer, that is 53 to 375 miles in height. This layer contains the ionosphere, where radio waves are reflected back to Earth and where the auras occurs. The temperature in the thermosphere decreases with altitude due to the absorption of solar radiation. The last layer of the Earth is exosphere. The exosphere is the outermost layer of the Earth's atmosphere. It ranges from the 600 kilometers, that is 375 miles, to 10,000 kilometers, that is 6,200 miles in height, gradually fade in space, and few particles are there. After that, we come to know that what are the Newton's laws of motion. Newton's laws of motion are three fundamental principles of physics that describes the behavior of object of motion. There are they were first described by Sir Isaac Newton in this 1687 book, Philosophy Naturalis Principia Mathematica. The three laws are: the first law is the law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by a net external force. This means that object tend to resist changes in their motion, and this resistance is called as inertia. You can see in this diagram the Newton's first law is shown by this image. An object at rest will remain at rest unless acted on by an unbalanced force. An object in motion will continue with constant speed and direction unless acted on an unbalanced force. After that, Newton's second law of motion, that is, the acceleration of an object depends on the mass of the object and the amount of the force applied. So here you can see the second law of motion, uh, the law of acceleration. The acceleration of an object is directly proportional to the net external force acting on it and inversely proportional to its mass. This means that the greater the force is applied to an object, the greater is the acceleration will be. And the more massive the object is, the less its acceleration will be for the same force. Here you can see in this image the law, third law, the law of action reaction. For every action there is an equal and opposite reaction. This means that when an object exerts a force on an object, the second object exerts an equal and opposite force on the first object. Together these laws explain how object moves, how forces affect their motion, and how they interact with each other. They are essential to study of mechanics and have practical applications in many areas of science and engineering also. In this image you can see that Newton's third law of motion, force will come in pairs. So now we can see the Kepler's law. Kepler's law referred to three scientific laws that describe the motion of planets around the Sun, which were discovered by the German astronomer Johannes Kepler in the early 17th century. The three laws are as follows. The first law, the law of ellipse. The orbit of every planet around the Sun is an ellipse, where with the Sun at one of the two foci of the ellipse. The second law, the law of equal areas. A line that connects the planet to the Sun sweeps out equal areas in equal time. The third law, the law of harmonies. The square of the orbital period of planet is proportional to the cube of the semi-major axis of its orbit. These laws provided a major advancement in the understanding of the movement of celestial body and were a critical foundation for later theories, including Isaac Newton's laws of motion and gravitation. So here you can see the second law of motion, second law of Kepler's second law. A radius vector joining any planet to the Sun sweeps out equal area in equal length of time. Here you can see that suppose this is area A1 and in this is area 2, they sweeps same area within equal amount of time. It will take 1 month for this area also, and it will take also 1 month for this area also. So that means area A1 is equal to area A2. Thank you.